we are going to start drawing the graphs. And I do have a handout for you. So, we have certain steps that we are going to go through. There is one thing we have to write down in our notebook still that's not on this handout. Sorry, so keep that out for just a second. And we may still go back and reference the asymptote for this. So the first step will always factor the numerator and denominator. When I ask you to do any of these on a test or quiz, I'm not expecting you to remember all the steps. I will break it down and say, part A, do this. Part B, do this. So I will prompt you for what you need to find. So then we'll write it in lowest terms, see if anything cancels out. We will find all of our intercepts, x-intercepts and y-intercepts. We'll find the asymptotes, vertical and the horizontal or oblique. Then we'll plot it all and draw a graph. One thing that I want to talk about, this is the piece that we need to put in our notebooks. Sometimes we get a hole in the graph. So a hole is what happens when something cancels out of the numerator and denominator. So when I look at this, if we have x squared minus 9 over x plus 3, the first step I would say, if we're going to graph this, is to factor. How do you factor x squared minus 9? What does x squared minus 9 factor into? Okay. Over the x plus 3. What happens? These x plus 3's cancel. So what that means is there is a hole in the graph. And when that happens, I am going to expect you to give me an ordered pair, because we're going to plot it as an open circle on our graph. So to find this, look at the thing that canceled, x plus 3. What makes x plus 3 equal 0? Negative 3. That's the x value. To find the y, you plug negative 3 into what's left. So negative 3 minus 3 is negative 6. So on this graph, I would have an open circle at negative 3, negative 6. We will look at some cases where this happens. Does everybody see why we have a hole in this graph and how I got that order here? So the handout I gave you has a ton of examples on it. We are definitely going to do some 3 or 4 for sure. We can do more as needed. So I'm just going to kind of be asking you guys for feedback as we go along. How many do we need? Do we understand? Yes?
Is this like what we did yesterday when you showed us that you can't cross them out?
Yes. So it has to do with the domain. For this, when we're reducing these, we'll go ahead and cancel it. But when we cancel something, we still have to write down what made it equal 0, because it will affect our graph.
So some of them we can cancel, some of them we can't?
Right. If they're not the same, we can't cancel them. But all right. So let's take a look at one. We're going to start our graphing now. Okay, so here is our first example. Step 1, top of your handout, factor. X minus 1 cannot factor. What about x squared minus 4? Okay. Does anything cancel? No, so there's no hole in this graph. All right, so second step was write it in lowest terms. Nothing cancels, so we get to skip that. X and y intercepts. Okay. An x-intercept is when y equals 0. So that's like this whole thing being equal to 0. What would you do if you were trying to solve this? Multiply by the denominator, right? What's 0 times anything?
0.
So when you're finding the x-intercept, it's really just what makes the top equal 0. And so if you remember that, you don't necessarily have to show me a lot of work here. What makes the top 0? 1. So my x-intercept is at 1. Y-intercept, what's true about x? X is 0. Does it matter if you put it into the original or the factored? No, it's going to equal the same thing. So it'd probably be easiest if we just did it right here. 0 minus 1 is negative 1. 0 squared minus 4 is negative 4. So we get a positive 1/4 for the y-intercept. Okay, asymptotes. Vertical asymptote we were working on for the first time yesterday. Where did that come from? The bottom. What makes the bottom 0? Yeah, negative 2 and positive 2. Please write those as equations because they are lines. Alright, then we have to decide. It will either be horizontal or oblique, not both. That's based off the degree. What's the degree of the top? The bottom. So our rule yesterday, if the top has a smaller degree, what is it? So we have a horizontal, y equals 0. Alright, that's all the information I'm going to ask you to find. Now I want you to put it on the graph. So intercepts, those are just points. We hit the x-axis at positive 1, the y-axis at positive 1/4. Asymptotes we draw as dashed lines. So we have a vertical one at positive 2 and negative 2. And a horizontal at 0. Okay, you'll notice there is a point on my horizontal asymptote. That's okay. You can cross through a horizontal asymptote in the middle, so it's not, we haven't done anything wrong here. The final thing, to figure out the graph, we're going to use our calculators to help us. I recommend always going back to the original. That way if you've made any mistakes along the way, you'll kind of catch them. When you graph, you need parentheses around the entire numerator and the entire denominator. So I go to my y equals parentheses x minus 1 over parentheses x squared minus 4. Right. When you draw this on your graph, we have plotted everything I expect you to have exactly. The rest of it, I'm looking at the big picture. So your asymptotes, you should be getting closer to those. Okay, your graph, polynomial, we're graphing rational functions, it should be curves. So I shouldn't see any corners. I don't want to see, something like this. Is that even a function? Does it pass the vertical line test? No. I don't want to see like this, because what's happening as I get closer to my asymptote? The graph should be approaching it. So I'm looking at this, my graph starts out negative, so it should be approaching my asymptotes. Okay, the middle section, it starts up, it comes down. I have to make sure I go through my 2 intercepts that I have marked. And then the final section was up here. Questions about what I'm looking for? So at this point, I've taught you everything. We're just practicing, okay? I have nothing new to throw at you. We're just going to keep practicing until we feel okay with it. So let's take a look at this one. So step 1, factor. What do you do with x squared minus 1? Over x, nothing I can do with that. Does anything cancel? Nope. So then we move on, x-intercepts. What is the fast way to find an x-intercept? What makes the top 0? Which would be 1 and negative 1. How do you find the y-intercept? Put in 0 for all of your x's. It doesn't matter if you use the original or the factored. If I do that, I get negative 1 over 0. Does that work? We can't have 0 on the bottom, so we just say none. There's no y-intercept. Okay, then we go into asymptotes. So vertical asymptote, x equals, what makes the bottom 0? 0. Horizontal or oblique, what's the degree of the top? Degree of the bottom. So if the top is 1 bigger, it's an oblique, everybody's favorite. How do we find an oblique? Long division. Okay, so we have x squared. If you want, you could put in a 0x. Not required, it just kind of helps organize your information. So, divide. What is x squared divided by x? Multiply. X times x is x squared. Subtract, those cancel. The next term is just 0x. What is 0x divided by x? 0. So I get x plus 0, or I could just say y equals x. So then we graph. So x-intercepts, I hit the x-axis at positive 1 and negative 1. We don't hit the y-axis. Vertical asymptote at 0, that is the y-axis. That's why we didn't have an intercept. And then oblique, y equals x. This is just a line. Y equals mx plus b. So my y-intercept is 0. Slope up 1 over 1. Whoops. I started at 1, didn't I? Sorry. Y-intercept is 0, up 1 over 1. It's just the identity function. Alright, and then to get our graph, we use our calculator, put parentheses around the top. Bottom is just one term, so it doesn't matter if you have those parentheses or not. And so we see our graph looks a little weird, but we've got to make sure we're going through our intercepts, getting closer to our vertical asymptote, and then coming down, getting closer to this oblique one. So it looks something like this. Is that one okay? Let's do... Go ahead and look at this one. First step is factoring. Do I have to do anything there? No, it's already factored. So, does anything cancel? Nope, so I jump straight to intercepts. So x-intercept. What's the fast way to find that? Now, when is the top 0? So that's -1. Y-intercept. If you plug in 0 for all of your x's, you get 1 over 0 times 4. So 1 divided by 0, can we do that? No, so there is none. Vertical asymptote. X equals, what makes the bottom 0? 0 and negative 4. Alright, horizontal or oblique. What is the degree of the top? 1. The bottom, if you multiplied it out, we would end up with 2. We have 2 x's, it would give us an x squared. So the top is smaller, so that means it is y equals 0. X-axis at negative 1, 2 vertical asymptotes. This one I did intentionally. When you go to put this in your calculator, be very careful. You need parentheses around the top. When the bottom is factored, this is when people make the most mistakes. Before you put it in your calculator, put another set around the whole bottom. Yeah, it's negative 4. I just wasn't paying any attention. Sorry about that. Okay, so then when you graph it, we can see this portion is down here. This one comes down. Make sure you cross your axis at your intercept. Please make sure you are drawing curves for me. I don't want to see little boxes or U's everywhere. One that has a hole in it because we haven't done any of those yet. So I'm going to skip. Let's go to this one. All right. So first step, factoring numerator and denominator. So what do I have to do to factor the top? Slip and slide. All right, multiply to 4, add to negative 5. And then we have to divide by 2. So we get 2x minus 1 times x minus 2. X squared minus 4. X plus 2, x minus 2. What happens right now? Yes. Those cancel. Okay. So everything that I do from here on out is going to be based off this final piece. But when something cancels, what does that do to my graph? It makes a hole in the graph. So we have to find it. The x value comes from what canceled. So what makes x minus 2 equal 0? 2. To get the y value, you plug a 2 into what's left. So I would get 4 minus 1, which is 3, over 2 plus 2 is 4. So 2 3/4. Does everybody know where that came from? Yes, ma'am.
So we got the 2 from the original exercise.
Yes, the thing that canceled. Alright. Everything else is the same. So x-intercept, what makes the top 0? 1/2. Y-intercept, if I plug in 0 for all of my x's, I get -1 on top, +2 on the bottom. Vertical asymptote, what makes the bottom 0? X equals -2. Horizontal or oblique, what's the degree of the top? And the bottom? Yeah, you could base this off the reduced one, where they both have a degree of 1, or the original, the degree of the top is 2 and the degree of the bottom is 2. Either way, when the degree is the same, what does that mean? So horizontal asymptote, and it's 0 when the top is smaller. When they're the same, the ratio of leading coefficients. So it's like 2x squared over 1x squared. So y equals 2. Alright, so now we have to plot everything on my graph. So if the x-axis at +1/2, y at -1/2, vertical at -2, horizontal at +2. And how do I mark the hole on the graph? Open circle at +2 3/4. Okay, when you go to graph it on your calculator, it does not matter if you do the original or the reduced. So I'll just go with my original, parentheses around top and bottom. Make sure when you're drawing this that you don't accidentally fill in your open circle. It's on the curve, but it is open. Your graphing calculator will not show you that open circle, so you do have to find it yourself. All right. Questions? We think we can try some? All right. So I am going to give you a handout. I'm going to take off a few problems here. So on the handout, I want you to do 1 through 3